So for number 8 here, it's got 4 terms. And so we would lean towards doing factoring by grouping. You have 4 terms, they don't tell you anything else. Usually you're going to do factoring by grouping. This one does have a little catch, but let's just start at factoring by grouping like normal. I'm going to look at the first 2 terms and decide what do they have in common. What goes into 2x cubed and 6x cubed? An x squared. What else? A 2. Does that make sense to everybody? So those 2, I can take out a 2x squared, and then I write what's left over here. We have another x there, and then here we just have a minus 3. That way if I multiplied it back in, I'd get my 2x cubed back, I'd get negative 6x squared. We're set there. For the second set, right here, what goes into negative 8x and 24? Right? 8 goes into both of those. 8 goes into 24 3 times. So if I take out this 8, I might want to take out a negative 8 here so that this becomes a positive x. This then would become a negative 3. Does that make sense to everybody? And that's our goal, right? We want these to match. X minus 3, x minus 3. If they match, I can take both of those out, essentially like a big greatest common factor. X minus 3 was multiplied by a 2x squared and by a negative 8. Here's where we have a little bit of a problem. This, as it is, doesn't look like it's going to factor nicely. But is there something that I can factor out of both of these terms? A 2. I can take that 2 out. The x minus 3 would still stay the same, but then this would become x squared minus 4. The reason that happened is if you look back at the original one, do you guys see that all 4 of those terms were divisible by 2? I could have factored out a 2 at the very beginning, which would have made this a little easier. Since I didn't, I had to factor it out here halfway through so that this becomes the difference of squares that we're used to seeing. So we can take that x squared minus 4, x minus 2, x plus 2. We still have the 2 out in front. And we have that x minus 3 that's been out there the whole time. So this problem said factor it completely over the integers. That part's done. Part B, find all the roots, real and imaginary. So all these set equal to 0. This 2 is never going to equal 0 on its own. But this, x minus 3, would be equal to 0 if x was 3, right? You could always set it equal to 3 if you need, or sorry, set it equal to 0 if you needed to. Subtract, and then no, in this case, add 3 to both sides and get x is 3. This one, x minus 2 equals 0. Add 2, we get a positive 2. This one, a negative 2. Is everybody comfortable finding those zeros or x-intercepts? If you need to see me set it equal to 0 and solve, let me know. I can do that, but I think most of us are pretty comfortable at this point just taking the opposite and finding those answers. Part C asks, how many x-intercepts are there? Well, we have 1, 2, 3 unique numbers here. None of them are imaginary, so that is 3 x-intercepts. Does that make sense to everybody? Any other questions on the front page? All right, so number 6, this one has 3 terms, so factoring by grouping doesn't work. It's got x to the 4th, x squared, and no x's. These 3 terms don't have anything in common, so I can't do a greatest common factor. Instead, I'm going to factor this with x squared and x squared, looking for 2 numbers that multiply to 36, negative 36, and add up to 9. So again, I've shown you a few times the area model here. You can use this if it helps you to factor, saying I need it to multiply to make x to the 4th and negative 36. We've decided already that x to the 4th should be x squared times x squared. But then what do I multiply, or what am I adding or subtracting from each of those so that these 2 middle boxes, when I multiply it out, those 2 add up to 9x squared. So I could just guess, well, 36 is 6 times 6. Let's try a plus 6 and a minus 6. That definitely doesn't work. I get a 6x squared and a negative 6x squared. Those add up to 0, not 9x squared. So that one's no good. Try again. Anybody think of two other numbers that multiply to 36 besides 6 and 6? Go for it.
3 and 12.
3 and 12. Is everybody good there? 3 times 12 would make 36. So let's try that one. I've got 12 and 3. That's going to make 3x squared and 12x squared. Right now, though, 12 and 3 doesn't make negative 36. I need one of them to be negative. And so right now, we're getting the idea, yes, the 3 needs to be negative so that I end up with a negative 3x and a positive 12x. That does add up to 9x squared. Does that make sense to everybody? So now, those are my two factors, x squared plus 12, x squared minus 3. Those do not factor. Neither of those is a difference of squares. So I'm actually done with the factoring here. But I still need to find the roots. I need to know what makes this equal to 0. So I take each of those. X squared plus 12 equals 0. And x squared minus 3 equals 0. This one, I can subtract 12 from both sides. X squared equals negative 12. Take the square root of both sides. X is equal to plus or minus the square root of negative 12. The square root of negative 12, well, I can factor that 12 out. 4 and 3, 2 and 2. I've got a pair of 2's. X is equal to plus or minus pair of 2's. The negative would be an I, and then a 3 left inside. Is everybody okay with that? And again, I've lost track of which classes I've mentioned it to. We're going to be doing a lot more with square roots next semester. The very first unit is going to be on square roots, cube roots, fourth roots. So we're going to be doing more of this starting off next semester. The other one works out a little bit nicer, or at least a little bit easier. X squared equals 3. Take the square root of both sides. X is equal to plus or minus the square root of 3. Doesn't reduce. Nothing else I need to worry about. Those are my 4 roots. How many x-intercepts do I have? Just 2. These are x-intercepts. These are not, because they're imaginary. They will not show up on my graph. So I have 2 x-intercepts. Are we okay with that one? All right, let's look then at the back page. Same stuff, except we're going to put everything together into graphing. So 11, 12, 13, 14 all tell you to factor. If you need, well, actually, they just say sketch the graph, but that requires it to be factored. Number 11 is already factored. I don't have to do anything extra with it. That one's ready to go. 12 is going to need to be factored. 13 is partly factored. You're going to need to finish it. I'm going to do 14 for you because that one requires probably the most factoring. And then I'm going to assume that you guys can go back and do the other 3 in the same way, knowing that most of them actually require less work than this one. 4 terms, probably going to be factoring by grouping. So I'm looking at the first 2. Looks like an x squared, but I'm left with an x and a 1. Second set, looks like they share a negative 9. Take that negative 9 out, leaving me with x plus 1. Is everybody okay with that first step of factoring by grouping? So now those are they both have an x plus 1 factor. I can take that out, be left with x squared minus 9. And this is then a difference of squares. X plus 1 times x minus 3 times x plus 3. I can now get my roots, my x-intercepts from that. X-intercepts are going to be negative 1, positive 3, and negative 3. I can come back up here and get my end behavior from that x cubed. X cubed is odd and positive. Odd positive means low, high end behavior. Low, high end behavior. Then I can get my y-intercept by putting in 0 for x. 0, 0, 0, minus 9. Y-intercept is negative 9. Now remember, when I plug in those zeros for x, this time just becomes 0 plus 0 minus 9. If I did that like here, I'd get 0 plus 1 times 0 minus 18. So I'd have 1 times negative 18. Just whatever the format is, wherever you're plugging in 0, plug in 0 for x's, and then simplify. This is now enough for me to make my sketch. X-intercepts at negative 1, and negative 3, and positive 3. Y-intercept at negative 9. I can connect the dots here, starting low, ending high. So down here, up, down, and up. There's my graph. Again, on a multiple choice test, I would be checking, are the x-intercepts in the right spot? Is the end behavior correct? Does it have the right y-intercept? Does that make sense to everybody? The others here are going backwards. 15 through 18 is, here's a graph or a description of a graph, give me the equation. So I'm going to go ahead and do 15 for you. 15, I see an x-intercept here and here. So negative 3 would have a factor of x plus 3, so that when I put the negative 3 in, it makes it 0. This one would have an x, the x-intercept is 4, the x minus 4 for the factor. Does everyone see it bouncing off there, though? So that one is squared. Y is equal to a. That's an equation, but it tells us to find the equation. So to find the equation, I'm going to plug in whatever other point they give me. In this case, they give me the y-intercept at 0, 6. So I plug that in. 6 is equal to a times 0 plus 3 times 0 minus 4 squared. I'm going to move it up here now. 6 is equal to a times 3 times negative 4 squared. Negative 4 squared is 16. 3 times 16. 3 times 16 is 48. Divide both sides by 48 to get a by itself. 6 does go into 48. Goes in, I think, 8 times. So we'd end up with 1 over 8 equals a. Plug that back into the equation we had. Y is equal to 1/8 x plus 3 times x minus 4 squared. Sorry, that's not very clear. X minus 4 squared. Does that make sense to everyone? You would do the exact same thing for 16. 17 and 18 is very similar, but instead of them giving you the graph, they just describe it. So like for 17, fourth degree polynomial with roots 0, multiplicity 2. A root at 0 would be just an x minus 0. Multiplicity 2 means it's squared. Another 0 at x minus 1, and another one at x minus 3. Y is equal to a times all that. Then they give us the point, -1, 12. F of -1 equals 12, that's a point on the graph. Plug it back in and solve for a. And then the last two down here, 19 and 20, are exactly what you're doing on the front page. You're factoring it any way, shape, or form, and then giving us the zeros or roots for each one, and saying how many x-intercepts does that function have. It's the exact same thing we were doing for 4 through 10. Does anyone have any questions about Unit 3's review?